And then also there'll be the recording because I'm recording that screen right now. Okay? So the reason I drew this line is because I want to talk about the difference between my like terms being on the same side and being on opposite sides, right? When they're on the same side, I can just put them together. 3x minus 5x is going to give me a negative 2x plus 5 equals negative 8x plus 15, right? Now I'm still in the like term stage here. Yes, sir. I'm still in the like terms, but this time my like terms are on opposite sides, so I can't just combine them, right? They're on opposite sides, so I have to cancel it off of one side. It's still like terms, so I still have to put those x's together. Negative 2x plus 8x is going to give me a 6x plus 5 equals
15.
Yeah. All right, so now I'm just going to have to get rid of, and I got that 6 times x is equal to, and I'm going to divide by that 6. All right, now, probably including me, we're all going to hit a calculator at that point, right? 10 divided by 6, but you're actually doing more work than what you need to, right? 10 over 6. Can that reduce? Divide them both by 2, and I get 5 over. And you know what? There's your answer right there. If it's a fraction, if it doesn't divide out evenly and your answer ends up being a fraction, simplify it if it does, and then you have your answer. Okay? All right. What about that? This out the way. Come on, you. And let's pull out this one. All right, what are we going to do with all of those fractions?
That's supposed to be 2 or 6.
2. We'll get rid of that and make that a z. 2. Okay, what am I going to do? Make that test a little bit harder.
Did I tell you I was a little nice?
Oh, thank you. Okay. Bring it down a little bit. All right. How am I going to make all of those fractions disappear? Common denominator, right? What is the smallest number that I could divide by 3, 2, and 4?
No. 12.
12,
Yeah.
right?
Oh.
3 goes into 12, 2 goes into 12, and 4 all go into 12, right? So here is where I'm going to want to wrap the whole thing and distribute a 12, okay? Because that's going to make them all go away. What is, remember we multiply by the top number and divide by the bottom. So 12 times 2 gives me 24 divided by 3.
8.
So 2/3 x just become 8x, right? Now, everybody, whether it's a fraction or not, I got to hit every single term. So 12 times 1 divided by 4.
3.
Okay? 12 times 1
Wow.
divided by 2.
6.
12 times 3
38.
divided by 4. Right?
6.
Now I have the same exact equation. It's equivalent,
Tripping.
but all those all of those fractions are gone. This is doing, I don't care if you get it right or wrong. If you're doing, you're moving. I promise it's an excellent thing. All right. I got to get those x's together. Combine them. Yeah. But they're on opposite sides of the equal sign, right? So I can't just put them. I don't have 14x, do I? I got to get it off of one side, move it to the other, and you've got 2x equals 9. 2-step. Subtract that 3, divide by that 2. And x equals, yes? You want to make your quiz tonight. Remember, you're going to have, on Wednesday nights, you're going to have a 10 to 15 question quiz. It's not in MathLab. Doesn't have anything to do with MathLab. It's in Canvas, right? You'll have till Sunday to get it done. There will be several of them. I'm not going to say I'm going to make it every Wednesday, but most. And all of that is going to come out to being about another test grade. Okay? But it's going to be one you're going to be working on your own. It'll be a one-shot deal, and Sunday night it closes up. Don't wait till Sunday night to take this quiz. Okay? Power goes out. Ooh. Right? Take it, be ready for it, and take it when you can. So these equations are going to be on there, right? All right. How many different types of answers can I end up with when I'm solving equations? Like on here, I had an 8x plus 3 equals to 6x plus 9. And how many answers did I come up with? Just one, right? 3. 3 is the only number in the entire world that can make that equation a true statement. What if I had 8x plus 3 equals 8x plus? How many answers would I have had, will I have for this one? Is there any number in the world? What if I went, let me take this step right there, and I'm going to say minus 6x or minus 8x minus 8x. What do I get left with there? That's gone, and that's gone, and 3 equals.
So that, okay.
Is that true? Does 3 equal 9? No. So you know what that is? Remember? No solution. One solution, no solution. What if you get things all simplified down and you end up with 8x plus 3 is equal to 8x plus 3? You've done your like terms, you've done your distributing, and you get everything all simplified, and it's exactly the same thing on both sides. All real. So don't forget, one, none, and all. Okay, those are possibilities, all right? And I promise you, you'll have one of these on that quiz, all right? All right, last thing from, that's not what I wanted, go away. last week that I wanted to go over was, come on. All right, I need B2. I need to figure out what B2 is equal to, but I don't have any numbers, right? So I just got to move things around. When you think the first step is going to be to solving this one, get that B2 alone. Whenever I have a rational expression, a fraction looking one, I'm always going after that denominator first. Exactly. Times 2 times 2. So that step is going to leave me with 2a equals h times b1 plus b2. All right. I want to get rid of these parentheses. So that means h has got to go. They're multiplying by h, so I'm going to, you could go that route too. Your answer will look a little bit different, but it'll technically be the same. 2a, I'm trying to get the b2 by itself. Get rid of absolutely everything up there but the b2. Equals b1 plus b2. All right, I only got one more step left. I want b2 alone. So who do I need to get rid of? Perfect. So if I subtract that b1, I've got 2a divided by h minus b1 equals b2. There's your answer right there. Okay? Because of the lack of numbers, it's kind of iffy, but all I'm doing is the opposite operations to get there. Okay? Yes? These generally need pretty good amount of practice. Let's try, so that was area of a trapezoid. So let's say, 2 times length width plus 2 times length height plus 2 times width height. Do you remember that one? Surface area. No. We haven't been on this earth a long time yet. Come on. All right. Let's find out what is h. Right? So do I have a term that doesn't have any h in it? So it'd be a pretty easy thing to just get rid of that term, right? Just move that term on over. I'm going to say minus the 2LW. So I have S minus 2 times length times width equals 2 times length times height plus 2 times width times height. Now my height is in 2 terms. And I got to get it alone. So that means I have to take it out of those 2 terms. This is where I'm going to do like that distributive property backwards. If I take h out, what am I left? If I take the h, I divide the h out of that one, I have, And if I divide the h out of this one, h times that parentheses, right? My goal is to get that h alone. So all I got to do is divide.
Like on the test, if I just skip this part, like the second part, like the end, and just go straight to the bottom, would I still get credit? Because that's what I was about to do.
We'll go ahead and talk about that a little bit. So when we are taking our test, I'm not going to trust that that's sanitizer. When we are taking our test on a multiple choice, you don't have to show me anything, right? Problem is that if the problem's worth 4 points and you show me nothing and you get it wrong, you lose all 4 points, right? But what if you got it wrong, you chose the wrong answer, but on a piece of paper, I got all of your work, and like in the very end, you left off the 2 or just did something silly, right? Just one of those silly mistakes there at the very end. Well, now you're only going to lose 1 or 2 points instead of all 4. You got the wrong answer still. You chose the wrong letter, but you showed me that you knew how to do the problem, right? So I got the option of doing partial credit. Okay? Does that answer?
Yes.
Okay. Because I don't know that you knew any of it if I don't see any of the work. For all I know, you just went and said A, B, C, D, E, F, G, So, but if you show me your work, then I got that option. Okay? On the open-ended, you're going to have to show me the work. That's a flip side. On the open-ended, if all I have is the answer, even if it's the right answer, you're not getting all the points. Because on an open-ended, you've got to show me all the steps. Yes? Did anybody try Wolfram Alpha out? Wrote it on the board? Yeah, it's a good math place, guys. It'll help you, and it'll show you the steps. You don't have to pay. Like math, whatever that is, Mathway is one that'll solve the problems for you. But it won't show you any steps until you pay. So you actually buy. If you do Wolfram Alpha, it'll show you the steps without you having to pay. Okay. All right. So today we are going to start with our quadratic equations. Yay! How exciting!
I got a question.
Yes, sir.
For the test, you like what are you putting like on the first test? Are you putting
Unit 1 test is chapter 1. 1, 1, 1, 2, 5, and 7, and 3. 1, 2, 3, 5, and 7. Okay. Now you know that your final exam and in May is comprehensive back to last Monday, right? The final exam the university puts out that you take your very last test, that's going to be comprehensive the entire course. And that's 25% of your grade. Yes? All right, so everything comes back to visit. We're never actually quite done with anything. All right, quadratic equation. Remember what that looks like? Ax squared bx plus c equals 0. Factoring? No, kind of, maybe. Okay, all right. You guys gonna have to, it's gonna be real important that you guys, keep talking to me. I don't care how many times you get the right answer, how many times you get the wrong answer, don't stop going back and forth, okay? Because that's what's gonna keep you in the game. All right, we gotta break this down. We gotta factor this. So we gotta break it up into pieces, parts, okay? And they're going to get broken down into two binomials, right? If my C is positive and B is positive, your signs there are both going to be positive. If my C is positive, but my B were to be negative, then both of these signs in here are going to be negative, okay? We're getting to actually explaining it a little bit more. That's just, Now, if I have a x squared plus b minus c bx, and my c is negative, I want you to know when you get to this point, one's going to be positive and one's going to be negative. Okay? All right, let's try one, and you'll see a little bit clearer what I'm talking about. All right, if I have, let's say I've got x squared A is 1, B is 5, and C is 6, right? My C is positive, so when I want to break these down, what am I looking for? I need two numbers that if I multiply those two numbers, I get a 6. But if I add those two same numbers, I get a 5. 2 and 3, right? 2 times 3 gives me 6. 2 plus 3 gives me 5. So I would break this down to x plus 2 and x plus 3. Yes? Getting some recall on it? Y'all were bad students in the classroom, weren't you?
I was a bad student. I graduated high school in 2011.
Okay. That, I'm not even going to mention what year I graduated high school.
It's not fair, you're a math teacher.
I don't share this much. High school dropout.
All right, I'm shut up.
I did not make it through high school. I was a very bad student in high school. I wouldn't go with that teacher. She couldn't tell me nothing. And then I learned I sure wished I'd listened to that teacher. So I started with Troy University at like one class above 99. One step above 101 when it comes to math. So doable. The only reason why I started teaching was everybody going, I can't do this math, this is hard. And I'm like, stop talking about it being so hard because it's just not that hard if you get that mindset out of your head. It's really, really not. All right, let's try another one. What if I have x squared what could I multiply that would give me a 15, but if I add, I'd get a negative 8. 3 and 5, right? Not just 3 and 5, but negative 3 and negative 5. So I would have to say x minus 3 times x minus 5. Yes? FOIL, remember FOIL? First, x squared, outside, minus 5x, inside, minus 3x, and last, plus 15. Like terms, x squared minus 8x plus 15. Right? Got right back to it. Yes? All right, that's factoring. When we factor, what we are looking for, guys, is where does that graph cross the x-axis? What was that U-shaped graph called? Parabola, right? Where it crosses is what I'm trying to get out of these things, right? So where it crosses the x-axis, let's say this is, we'll say this is 2 and this is negative 4. What coordinate? X is 2, what's y?
0.
2, 0. X is negative 4, y is? That 0 right there, that's why we set this stuff equal to 0. Because what answer I get is going to be this point right there on the x-axis. Now, I'm not going to do this one yet, but I do want to do this one, my first one here, because the first thing you always look for is that common factor. What, I've got 2 terms, not 3. I'm not going to break this down into my 2 binomials because I only got 2 terms. But what can come out of those 2? X. I can factor out an x. X squared divided by x is going to leave me with, and 6x divided by x is going to leave me with, and that equals 0. Okay, so maybe put some kind of star by our notes. This is not the answer. Everybody wants to give me this as the answer. It's not wrong, but it's not done. If I have A times B equals 0, what do you know about A or B? For me to get a 0 out here, somebody's got to equal 0. If I'm multiplying, the only way I get 0 when I'm multiplying is somebody has to be 0, right? Well, that's what I'm doing here. X and x plus 6 equals 0. Somebody's got to be a 0. So I'm going to take my first term x, and I'm going to say x equals 0. And I'm going to take my second term, x plus 6 equals 0. This is done. But this is not. I've got to get that x by itself. So x equals, so my solution set is 0, negative 6. When I go to graph this, like we're going to have to in 4, my graph is going to cross at 0 and at negative 6. That's the information I just found out here. That's what that's given me.
Hold on.
Mm-hmm.
So we're gonna go down to negative 6 and cross over.
Negative 6 and 0. Now the rest of this graph isn't accurate. The only thing I want you to understand is that these two numbers is where I'm crossing the x-axis.
Did you write that backwards?
Oh,
Okay,
okay.
that's where you got
That's
me.
where, okay. I didn't write it in order. Okay, that's good. Yes? Okay. When it's set, it's not necessary. It's a good idea to write it in order, but it's not necessary. Okay? But yes. So it's going to cross my x-axis at -6 and at 0. Okay? All right. Let's try a couple of these problems. Not that one. Let's start with x squared minus 9x equals 0. Factor that one out for me. Yep. Is anybody going on to 14? I asked this last week. It's 12 it. Was 11, 12 your last math class?
No, I think I still have another math.
I have no idea.
I don't take that much as
Oh, major.
I'm sorry.
the academic advisor for the football team do it, so I don't.
Okay. What's your degree going to be?
Psychology.
Psychology. So it's probably your last math class. Okay. All right. So what can I factor out of this one?
X.
X. So I'm going to take that x out, and that's going to leave me with so if these two multiplied are going to equal 0, then x equals 0, or x minus 9 equals 0. So my solution set is going to be 0 or yes? All right, let's try 15. Now 15 is a trinomial. All right, I'm going to clear this. What can I multiply that will give me a -6 if I add it up, get a positive 1? If I multiply, I get -6. But if I add, I get a 1.
6. No.
What are you?
That's what myself.
That's not going to add. That'll give me the 6, but it won't give me the 1. What about if I tried what's 3 times -2? -6, and 3 plus -2? That's 1, right? So that's what I want to factor this still down to. That means I can break this down to x plus 3 times x minus 2. So x plus 3 equals 0, or x minus 2 equals 0. Minus the 3, x equals -3. Add the 2, x equals 2. So my solution set is going to be -3, positive 2. And a little bit.
See, this isn't the bad part.
This isn't the bad part.
No, it's the part after this, with the big formula.
The quadratic formula.
Yes, that is the worst part of math I've ever learned.
Really? All right. I'm looking for some problems because I'm not going to do. Let's try x squared plus 5x plus 4. Okay. I want two numbers. If I multiply, I get 4. If I add, I get 5.
Four and 1.
4 times 1 is 4. 4 plus 1 is 5. So C is positive, right? And B is positive. So I'm going to have x plus 4 times x plus 1. And what's that last step? Because I'm not done.
So I had 5x.
X plus 4 equals, and x plus 1 equals 0. Subtracting that 4, x equals -4. Subtracting that 1, x equals -1. So that's my solution set, -4, -1. Any better?
We only do that for, what do we call it, trinomial?
Trinomials.
So we only do
1,
that,
2, 3. 3 terms.
well, imagine we only do that,
Yeah. Now this is me and scratch work. This, you don't even have to do that. This is me in scratch work. This is me writing things down.
that's how I'm learning, so that's how I'm gonna do it.
Okay, that's good. All right, how about oh God, I don't want to do that to you, but I'm gonna have to.
No, you don't have to.
All right, let's try one more of those. What if I have x squared What do we gotta multiply to?
28, negative 28,
Negative 28, don't lose those signs, and we're gonna add to
negative 3.
what two numbers?
Negative 7, no, yeah, negative 7 and negative 3. I mean, 4. Oh, God.
Positive 4,
Positive 4.
right? Negative 7, positive 4. 4 times 7 gives me 28, and one of them big negative give me a negative 28, and negative 7 plus 4 is going to give me a negative 3, right? So I'm going to break this down to x minus 7 and x plus 4 equals 0.
With C being a negative, where are we gonna know that one of the numbers is supposed to be positive?
Because C is negative, you know that one of these is negative and one's positive. Mm-hmm.
Oh, yeah, you said that.
Right.
Oh, yeah.
Well, and this being negative, you know you're going to add and subtract to get there, right? You know because this is negative, your bigger number is going to be negative. All right, so my last step, so adding 7 to both sides and subtracting 4 from both sides. All right? Little better? I got my students at Ozark on a 1, 2, 3. 1, I don't know what you're up there doing. 2, I think I'm doing okay. 3, yeah, I understand. So where would we be?
You know, I'm at 2.
We're at 2?
You can't speak for everybody else.
Hey, I'm glad with the 2. All right, okay. Gotta make it a little harder. Okay. I know, right?
It's even.
So, we're going to do almost the same thing. I got to add another level to it. We're going to look at 23. Okay? Now, first of all, what's the first thing wrong with problem 23? Is it in the quadratic form, ax squared plus bx plus c equals 0? No. So I need to get that 12x over here, right? So I need to do 4x squared, and I'm going to subtract this 12x from both sides. So I've got 4x squared minus 12x plus 9 equals 0. Now I'm going to do that same that square over here. But this time, up in this corner, I'm not going to just put c. I'm going to do a times c. Who's my a?
4.
And who's my c?
9.
So what's a times c going to be?
36.
36 in here. And then I'm going to put that negative 12, my b, in here. All right, now I'm on the same step as I was before. I need something that'll multiply to a 36.
12, negative 3, or negative 12, 3.
That won't give me a 12.
Oh, snap, I forgot.
Right?
It's adding to get 12, right?
Adding to get a negative 12. Right?
Oh, it's probably-
It's going to multiply. Now, what do you know? If I'm going to multiply to get a
9 and 4.
positive,
9 and 4.
One's going to be negative.
you're getting there. If it's going to multiply to be positive but add to be negative, then both of them are going to have to be negative. So think about how many ways can I multiply to get a 36? I got 1 and 36.
Oh, 8.
It's 32.
Is it?
No, that's not going to give me a 12.
I give up.
Don't give up that easy. Come on. Swing that bat a little bit more. What about 4? Okay, so I got 1 and 36. 1 plus 36, 1 minus 36. I'm not getting to 12, am I? Alright, I got 2 and 18. Well, that's not gonna get me anywhere near 12. Alright, I got 3 and 12. But I've already got 12. I can't. Alright, then there's 4 and 9. That would give me a 5. What about 6 and 6?
6 and 6.
Just that simple.
Would that get?
Y'all feel dumb.
Don't feel dumb. Trust me, I've been there. Listen, one of the best things that helped me with my math, and I'm not saying have kids,
I got
helping my kids with their multiplication tables. That made math a whole lot easier. Just getting those multiplications. All right, here's the thing. I'm going to still write this 4x squared down. And I'm going to write this 9 down. But instead of this 12, I'm going to write minus 6x minus 6x. Negative 6x, negative 6x, that's a negative 12x, right? So I haven't changed anything. I just broke the 12 down into these two terms. All right. Group them. Now I got to factor out, what can I pull out of 4x squared minus 6x? What's in both of those?
2. 2x.
2x. So if I pull a 2x out, what's 4x squared divided by 2x?
2x.
Okay. What about if I negative 6x divided by 2x?
negative.
Okay. What can I pull out of negative 6x and a 9? 3. I want to make it like this, right? So I want the signs in here to change. So I'm going to pull out a negative 3. So negative 6x divided by negative 3. Positive 9 divided by negative 3. All right, what do you see? Same thing, isn't it? That's my common factor. So I have 2x minus 3 times 2x minus 3. Ended up being the same thing. So all I have to do is 1, and I'm going to say 2x minus 3 equals 0. So I'm going to add 3 to both sides. 2x equals 3, and I'm going to divide by 2, and x is equal to 3/2. Now, this textbook's going to take you through several ways of doing this business. Some of them work for some equations, some of them work for other equations. We're going to start hitting that quadratic formula because that's the one thing that will work for every single equation. Okay? So, we're not really going to worry about all this. We're going to hit the quadratic formula. And we're going to let that, because if we have a formula, the formula tells me exactly what to do. Okay? So, no matter what, if you've got an x squared in there, you're going to follow this formula. Now remember, my equation is ax squared plus bx plus c equals 0. So from this, I get, here's my quadratic equation. X equals negative b plus or minus the square root of b squared minus 4 times a times c over 2a. Now I know that looks like a lot, but it's not, I promise. I'm going to take it one step. All right. We're going with 2x squared minus 5x minus 3 equals 0. Who's A? Who's B?
Negative 5.
And,
Negative 3.
okay, so I'm going to follow that formula. Negative B. What was my B? Negative 5. Plus or minus the square root of B squared. So negative 5 squared. Right? Okay, I'm gonna wait. I want you to, I'm gonna wait. I'm waiting. You look, see, catch up with me, okay? We're doing that formula.
What?
Where did what?
Okay.
Okay, minus. Okay, what's my A?
Yeah, that's 2.
And my C.
Is 3. Negative 35.
Nope. All over
2A.
2, and what is A?
2.
All right, filled in my numbers. All I did was take the numbers off of this equation and plug it in. What was B? Negative 5, right? So I've got negative, negative 5. Plus or minus negative 5 squared. Minus the 4. The 4 is going to be there every time. Times 2 times negative 3. Now we just got to simplify those numbers. Negative, negative 5 is a plus or minus.
So that's basically like the key to every problem right there.
Yep.
It is. It's like a cheat sheet. It tells you exactly what to do. So I have 5 squared. What's 5 squared?
25.
No, because the negative is
So it's
inside the
okay.
so it's positive. All right, negative 4 times 2 gonna be a negative 8 times 3 is gonna be a negative 3 is gonna be a positive. So what do I get there? 25 and 24.
49.
There you go. So now I've got 5 plus or minus the square root of 49 over 4. Where did I get that 4 from?
2 times.
Okay. What's the square root of 49? What can I multiply by itself that will give me a 49?
7.
1 times 1?
Oh, 7. Oh, was it 7?
7.
Oh, okay.
So this is 5 plus or minus 7 divided by 4. So what's 5 plus 7?
13, 12,
One less.
12.
12 over 4, which is 3. What's 5 minus 7?
-2.
Negative 2 over 4, which is a negative. And there's my answers. And I don't have to factor. Okay? I don't have to factor anything. I don't have to do A times C. All I have to do is follow this formula. All right, let's try that formula again.
Does it matter what kind of bracket you use? Because I've been noticing you've been using the squiggly one, so it's
These, I can't draw them, no braces.
I know
When
what
you
you mean,
do
but like
the
that-
set,
okay. I
That-
didn't know if it had to be the squiggly ones or just the little swoops.
oh, the parentheses, if I'm doing a coordinate,
Oh.
I'm gonna use but with these, the set I'm gonna use. All right, let's try, a little bit smaller on the numbers. We're gonna say, what's my A on this one?
1.
Mm-hmm. What's B?
8.
Negative 8, and C.
-2.
See if you can get that into that formula. What?
Alright, I'm stuck.
Yeah? Got our setup. All right, negative 8 makes a positive 8. All right, right here, 8 squared,
8 raised to the second power is 64.
Well,
4 times 1 times 12.
48. Goddamn.
Okay, so what is 64 minus the 48?
We hit the money there?
Subtract that.
Oh, that's what I messed up.
16.
Ooh,
14?
close.
14?
14, right? 64, 14 minus 8 is 6. And 5 minus 4 is 1. So you were right to begin with, weren't you? And I was wrong. Minus, plus or minus the square root of 16 over, what's the square root of 16? What can I multiply by itself? That will give me a 16. There you go. So 8 plus or minus 4 divided by 2. So this is two problems, right? 8 plus 4 divided by 2, 8 minus 4 divided by 2. So 8 plus 4 is divided by 2 gives me an 8 minus 4 divided by 2 gives me a
2.
2. There's my fabulous braces. Okay. All right, so between now and Monday, you're going to practice the quadratic formula, right? Make it easy. Memorizing it makes it a lot easier. And I know, of course, you are a West Virginia fan. Okay. All right, guys, we're going to close there. And this